Today, we attempt to determine the hardness of this elusive and extremely rare mineral. Will we be successful in our attempt? Come with us on the other side. Tiragalloite. Tiragalloite is named after Paolo Onofrio Tiragallo, an amateur mineralogist from Genoa, Italy. The strikingly orange mineral, with only a handful of localities known on Earth, is so rare and the usual crystals are so small that the hardness data have yet to be described. In fact, it is anything short of a miracle that we have one of these samples to make a video, let alone 4. The specimen originates from the same mine where it was first discovered, the Molinello mine in Italy. At the time of its first publication, in 1980, it was the first and only known mineral consisting of Arsenatotrisilicate ions, classified in a class called the Arsenosilicate, where arsenic replaces some silicon atoms. Since then, a few other minerals with similar arrangements have been discovered. Its discovery shook scientists, as they did not believe such an arrangement could be stable enough in nature and be discoverable by researchers. This arrangement is chemically unstable and not expected to persist for long under normal geological conditions. But there it was, waiting in the wings to be discovered by Paolo's biggest fans, naming it in its honor. Tiragalloite is monoclinic, with elongated, needle-like and sub-adamantine crystals, with a density of about 3.84 grams per cubic centimeters. It formed under relatively cool, water-poor conditions, which helped prevent it from breaking down. In my opinion, it is truly a remarkable mineral, as it should break down in most normal geologic conditions and not persist long enough for humans to discover it. One of its other environments in which it formed, in Austria, is in manganese-rich lenses within quartzitic-chlorite schists, which are probably derived from marine sediments. I discussed marine sediments in more depth in this video. Tiragalloite is so scarce that only a few localities have been found since its discovery. With all these flags, you have the entirety of the locations where you can find this mineral. Now, let's try to determine its hardness, the real juice of the video. I won't show you in details the whole thing, but I'll show the results. I only have 4 specimens. Because these crystals are so small, I look at the edges of my specimens to find a place that is suitable for making the test. Okay, so when I do a hardness test, let's say to identify a mineral, I always start with a steel blade. This is because steel has a hardness of about 5.5. So I look either at the edges or I look at crystals poking out. This will make the test much easier. And finally, I found one place that is almost perfect, that should work. So let's go ahead. Okay, so we can see the result of that test, which by the way, each crystal are about less than a millimeter in size. So you can see that there's a mark there. It did leave a mark on the blade, but it did not scratch it. It's a very good example because you can see that the mark is not a scratch. If I was to rub it off, the blade would be the same as before. So now we know that the hardness of Tiragalloite is under 5.5. That is our first condition that we have found for this test. Okay, so now I like to go in the middle between 1 and 5. So 3, it is calcite. You can watch the video there. Okay, so I just did the test. You can see the mark there. You can see it is a scratch. So this is the difference between the blade. It did left a yellow mark. The mineral did break down a bit by doing this test. So that tells us that Tiragalloite was able to scratch calcite, but some of it was left behind, so it did break down. So we're pretty close to 3 in hardness, So we're getting there. So we know now that the hardness of Tiragalloite is above or equal to 3 and below 5.5. So let's do the last test because we need to go right in the middle, which is fluorite at 4. Okay, so we can see that there's absolutely no marks there. In fact, it pulverized the little mineral I had to test. We now know that the hardness is below 4. Tiragalloite hardness is probably equal to 3 or 3.5. So my best guess would be that the hardness is 3.5 based on the calcite test and how it left a mark, and it did break it down a little bit. So here we are. We have been able to pinpoint a range of hardness for this mineral and have a better understanding of how and where it occurs on Earth. Maybe now we can finally add today's value to the missing hardness data. Tiragalloite, a mineral so rare that we are still shocked today at its presence and existence. But don't worry, our journey certainly doesn't stop here. There are numerous minerals that shouldn't exist but yet do, and we do find them in nature. We will definitely tackle them in future videos. For more on everything about minerals, visit my channel, Mendex. Thank you for sticking to the end, and please do not forget to click the like and subscribe buttons. Peace out. Test. For every...